that it is the more you practice, that the more you know it. So you need to practice a lot. It is not easy for you to see a question and be able to solve it. It is usually that you have seen such a question before, and so the experience that you have gone through before will assist you in solving such question. So that is why we always advise you solve as many questions as possible. That is what will always make you to be very good in mathematics. So I want you subsequently to make sure you do assignment. Sorry, I may not be able to answer the person now. Please, whoever that can assist somebody ITEL A56 to be able to connect to the audio. So you need explanation of how to connect to the audio. So that is, so please, whoever that can assist can just private chat the person. So I'm going to move on to today's work. So from what I have here, I have this. To be able to solve this, now what you just need to do when you see a question of this nature, we can just try to, we have it as logarithm of square root of 27. You know, anytime we have square root of a number, is same thing as a raised power half. So it means square root of 27 will be 27 raised to power half minus log, the same thing, 8 raised power half, all divided by that 1.5 is still the same thing as saying, you know, I told you something last week that anytime you see a decimal number, you convert it to fraction. So with 1.5 you see there, if you want to convert it to fraction, it will give us what, 3/2. I don't think I should talk about that one again, 3/2. I believe everybody understands how it becomes 3/2. So we just need to say 1.5 over 1. So you shift this point to the back of the last number, then you add 1 0. So 5 here 3, 5 here 2. So that is why it is like that. Then from there, we can see that we have what? The 27 is still the same thing as 3 raised power 3. Reduce it to. So we have logarithm of 3 raised power 3. Also raised to power what? Half. Minus logarithm of 2 raised power 3. Also raised to power what? Half. Divided by, now according to law of logarithm, when you have a logarithm of a divided by b, you can actually change it to what? Log a minus log b. So this is the same thing as log 3 minus log 2. So please, if you have anything, you can use the chat button to say whatever you have to say. So the next thing from there, you can now see that we have our power to be logarithm of 3 raised to power. When you multiply 3 by half, the powers, it becomes 3/2 minus logarithm of 2, the same thing, 3/2 divided by logarithm of 3 minus logarithm of 2. So from there, the 3 over 2 here, according to law of logarithm that we also discussed, this is an extra power. You also observe that we did not say anything about the base here. When they don't give you any base, it means that it is base 10. So that's why we don't even need to mention it. We don't need to put it there. So the power here is 3 over 2, extra power. You take it to the back, it becomes 3 over 2 log 3 minus the same thing here, 3 over 2 log 2 divided by what? Log 3 minus log 2. So now you can see that 3 over 2 is common at the numerator. So you take it out. 3 over 2 is common. What do you have left? You have logarithm of 3 minus logarithm of 2. Then divided by what? Logarithm of 3 minus logarithm of 2. Now, you can see that log 3 minus log 2 is a whole here. This is also a whole. Log 2 cannot cancel log 2 there. Log 3 cannot cancel log 3, but they can cancel as a whole. So the whole of log 3 minus log 2, we cancel the whole of log 3 minus log 2. And our answer will become 3 over 2. 3 over 2 is an improper fraction. You can just leave it as one whole number, 1 over 2. So that is the solution to that particular question. I want to believe that it's very clear. My explanation is very clear.
Yes, sir.
Okay. So, wow. Sorry, I think my system went off just now, but I'll power it back. Sorry about that. Okay. But you can still see question on the board. So for the question number 2, we have 2 log 2. That's 2 log 4 base 2. Okay. Sorry. Don't worry, I will. Yes, the recording of the classes, you can get it. You can get it, and that's why you can see it live on YouTube.
So, yes, sir.
After the class, you can also get it there.
Okay, sir.
Okay. So let me just look at the other questions and see if I can. If I can go to. Okay, so in continuation, question number 2. I will just yes, yes, my system went off. Sorry, I'm trying to connect back. So I'm using another this thing to. So I will do the explanation. I will explain on the whiteboard now. I will use the whiteboard. So as we wait for the system to come up, I can always make use of the whiteboard here to do 1 or 2 things. Okay, so for question number 2, I'm sorry. So, okay, I think I've seen. So for the question number 2, the question number 2 says logarithm 2 log 4 base 2 or 2 log 2 base 4 is equals to x plus 1. I think this one is very direct. This one is very direct. So what you just need to do there, okay, the next question is also what? Logarithm of what? 8 base 5 over logarithm of root 8 base 5. Okay, sorry, the system is just coming up now. Sorry about that, please. Okay, let me just use this time to. Okay, so as it's coming up, let me share my white screen here. Now, for the second question, we have log 2 log. That's the problem of phone. 2 log 2 base 4 is equals to x plus 1. So from here, what you just need to do is that before you can apply the law of logarithm here, you make sure that there is nothing at the back of the logarithm that you have here. So the 2 there, you take it up, so it becomes logarithm. It becomes logarithm of 2 raised to power 2, 2 raised to power 2 base 4 equals to what? X plus 1. So then from there, it's same thing as what? According to what we learned last week, this is the base, and this will always remain as the power. So we have 4 raised to power x plus 1. 4 raised to power x plus 1 is equals to this 2 raised to power 2. So 2 raised to power 2 is same thing as 4. So 4 raised to power x plus 1 is equals to 2 raised to power 2 is what? 4 raised to power 1. So base 4, then x plus 1 is equals to 1. So x is therefore equal to 0. So s equals to 0. So that is the solution to that particular one. For question number 3, I don't want to do that. I want to believe you can also try that on your own. So please try to look at number. You also need to solve so many questions. So I won't solve all the questions for you. So let me leave question number 3 for you to do. 967. So in continuation, I think my screen, my system is back. So now the next question, let's go to number 5. I will soon share this thing from here. Now let's go to number 5. Number 5 question, what do we have there? We have okay, let me look at number 4. There's something in number 4 that we need to get clearly. So I need to explain that one too. Okay. So in what you can see in number 4, you can see that we have logarithm of 3 to base 9. Logarithm of 3 to base 9. Sorry. Okay. I think my system needs to come back. Sorry about that. I think I'm just coming in now. Okay. Okay. Yeah. So please, I've just come in now. Let me. Okay, so wow, okay. I'm trying to, sorry, I think I need to. Okay, so I think it's coming up. Okay. Yeah, that's great. So okay, it still respond. Okay, yeah. So you should be able to view my screen now. Okay. Okay. So yeah, that's great. So the okay. So thank you for the patience. So in continuation, what we just need to look at there is that in that one, you can see that okay. All right. So now look at this. This one is this log to base 9 is not for 2x. It's only for is this. This is the only one that has logarithm. So it depends. You can give it different approach. You can just transfer this 2x to this side so that you are going to have logarithm of 3 to base 9 equals to 1 minus 2x. So I haven't done that. You can see, so it's like these are together, that's the result, which will be the power. You know, we have said logarithm is always the power to which a base is raised. So the power to which we raise this 9 to give us 3. So you can now say that 9 raised power 1 minus 2x equals to 3. Okay, I think somebody is trying to raise hand. Is there any question? Do you have any comments? You can make use of. Okay, for the record, I will send you. I will send you the link. No problem. Just hold on. So whoever that has any question, you can just put the question across in the group chat, in the chat. So equals to 3 raised power 1. Now this one you have to express it in terms of base 3. Since this is base 3, this is base 3. You have to make sure they are in the same base before we compare. So 9 is same thing as 3 raised power what? 2. So 3 raised power 2. Also raised to power of what? 1 minus 2x is equals to 3 raised power 1. So if the base are equal, then you deal with the power. So you equate the power. 2 into bracket 1 minus 2x equals to 1. So 2 times 1 will give us 2. Then 2 multiplied by this. That will give us what? Minus what? 4x, which is equals to what? 1. So from here, you can take 2 to the other side, minus 4x will be equals to 1 minus 2. This plus 2 will come to the other side to become minus 2. So we have minus 4x is equals to what? Minus 1. Then you divide both sides by what? By minus 4. So x will be equals to minus 1 over minus 4, which is same thing as 1 over 4. So that is the answer to that particular one. Now, if you look at that of 5, you can just evaluate this. If you evaluate logarithm of what? 125 to base 5. So what will it give you? Equate it. Logarithm of 125 to base 5. Don't forget that same thing as logarithm of 5 raised power 3 base 5. So this thing will go there. That is what you do there. Then for this particular one, okay, Bright said he has a question. Okay, can I pause for you now to ask your question? That's Bright. Bright, can you just raise your hand? Okay, I think I've seen you. So Bright, you can unmute yourself and talk.
So the second question, what was your answer, please?
Okay, the second question. Do I remember what we got? I think we got 0. Yes, we got 0.
0
for that one. 0, yes.
All right. Thank you, sir.
All right. You are welcome. So for number 6, I think I've mentioned that of number 6. What you just need to do there is what? Is to convert this one. Convert it to what? That's a decimal number. Convert it to fraction. So this is, you can equate it to x. Then you can say that 0.25 raised power x equals to it. So when you convert 0.25 to fraction, I think you should have 1/4 raised power x equals to what? 8 is same thing as 2 raised power 3. Then 1/4 is same thing as what? It's same thing as 1/2 raised power 2. From what we have learned earlier, it's same thing as 2 raised power minus 2. 1/4 is same thing as 2 raised power minus 2. X equals to 2 raised power 3. So if this, you cancel this, minus 2x equals to 3, and x is equals to minus 3/2. So, okay, what of number 5? I think I've explained number 5. What you just need in number 5, is this particular one. I said you can reduce it. It's same as logarithm of 5 raised power 3. 125 is 5 times 5 times 5, meaning 5 raised power 3, base 5. And when you have something of this nature, when you have this, it's still the same thing as what? 3 log 5 base 5. Log 5 base 5 will give us what? 1. This one will give us 1. So we are left with 3. So it means at the end of the day, we can just have what? Logarithm of what? Y raised power half base 2 is equals to 3. And don't forget that this is the answer of the logarithm is called the exponent, to which we raise this base 2 raised power 3 to give us the number y raised power half. So how do you solve this equation? 2 raised power 3 is equals to y raised power half. Don't forget that what we are looking for is y. So this half should go away. So how can we make that half to go away? We must multiply both the powers by the inverse of 1/2. The inverse of 1/2, when you turn 1/2 upside down, it becomes 2/1. So multiply this on 2 by 2/1. So at the end of the day, we are going to have 2 raised power 6 is equals to y raised power 1. So y is 2 raised power 6, which is same thing as 64. So that is the solution to that particular question. Let's quickly move. Then we also have simultaneous equation. I will not mention that simultaneous equation. It's just for you to be able to express. Now, also note that the 2 here has no logarithm. It is this that is together. So it means you have to introduce logarithm to these 2. So meaning that if you need to, let me just help you to simplify this. It's still the same thing as logarithm of y base 3, which is equals to logarithm of x base 3, plus you are going to introduce logarithm to these 2. It will be the same thing as 2 log 3 base 3 because we are in base 3. So these two will later come up here. So that we have logarithm of y to base 3 equals to logarithm of x to base 3 plus logarithm of 3 raised power 2 to base 3. So logarithm of y to base 3 equals to logarithm. So you can see now that we have log 3, log 3, log to base 3, log to base 3. So having got that, we can what? We can apply rule of logarithm since they have the same base. Then when you have addition, you multiply the what? The numbers. So x multiplied by 3 square is 9. So at the end of the day, we are going to have what? Log. We are going to have last log y base 3. Sorry. Okay. I'm coming. Let me just speak. Okay. So it will be log y base 3 is equals to log 9x base 3. So logarithm to base 3 cancel logarithm to base 3. So we later have y equals to 9x. That's the equation 2 here. So you can see how you can use your knowledge of indices to deal with this one. So that this one will become equation 1. And this that we have got, I've simplified this for you. That's equation 2. So that is how you are going to deal with that particular one. I want to believe that you are getting what my explanation there. Okay, so okay, so that is what the explanation to that. Okay, then let me, this one is very, number 9 is simple. Okay, let me talk about number 8. It's just for you to have an idea. Now in number 8, what you are going to do there, I'm not going to do number 10 again because I've done number 1 for you. Number 10 and number 1, they have the same structure. So I look forward to getting somebody that will at least feed me back on number 10. So I will do it for you. You can go and try it and then get back to me. So for number 8, now what you are going to do, in number 8, you can see that this one is, logarithm of x to base 3. Why this is logarithm of 3 to base x? You can see that they are of different base. So, and we have mentioned what happens when they are of different base. You have to change the base. So you need to decide which one do you want to change the base. Are you changing the base? Are you changing from base 3 to base x, or you are changing from base x to base 3? So whichever one you agree to within your mind. Now let's assume that we are changing. Let's assume that we want to change from base x to base 3. So what do we need to do? In that case, this one is okay. This is base 3. There's no problem with it. So it is this one that has problem. And don't forget, I think if I need to remind you that when we want to change to base, we said that we are going to have logarithm of, maybe we have a to b. We want to change to what? Let's assume that we are changing this particular base from base b to base n. So it means we are going to have logarithm to base n over logarithm to base n. Then the a, that is the number here, will be at the numerator as the number, and the b that is the base here will be the number of the denominator. So this is how we change the base. So you can see we have changed the base here. Base of log a to base b. We have changed the base from b to what? Base n. So the same thing here. The same thing here. So How do we do that? Come in, let me try to clean. Do I clean? Okay. So, okay. Let me see. Okay, clear. So yeah, I'm trying to clear. Okay, let me use this then. Okay. Sorry. Okay. So, okay, let me just continue. So what we are, well, the space here is not all that much. I'm trying to. Okay, that's great. Okay, it's clear already. So now what do we do here? So I'm changing the base. The first one remained the same, logarithm of x to base 3. I want to change the base of this one, 3. It will now become, I'm changing to base 3. So it will be logarithm to base 3 over logarithm to base 3. Then whatever I have up here, it will be up here. Whatever I have down here, it will be here. So plus 2 is equals to what? 0. Now you can see there is no rule that tells us how we can deal with something of this nature. Logarithm divided by logarithm. The rule that we know is just that when we have logarithm plus logarithm or logarithm minus logarithm, there's no rule that talks about logarithm divided by logarithm. So what I can just do here is that I can see that I have radicals. I have at least those that are proving to be stubborn. That's logarithm of x to base 3, logarithm of x to base 3. So let me represent it with something. Let logarithm of what? X base 3, let it be p. So anywhere I see logarithm of x to base 3, I will change it to p. So I'm going to have p minus 3. Log 3 base 3 is still what? It's still going to give me 1 over log of x to base 3. We have said anywhere you see logarithm of x to base 3, change it to p. I have p plus 2 equals to 0. So I can decide to multiply through by what? Well done. I can decide to multiply through by what? By p. So it means I'm going to have p squared minus what? When I multiply this one by p, the p down will cancel out. I'm going to have minus 3 plus multiply this one by p. I have 2p. When you multiply 0 by p, it give you 0. So at the end of the day, I have p squared plus 2p minus 3 is equals to 0. So from there, if I solve that, I have p, this is a quadratic equation. So that's p squared minus plus 3p, from what we have done the quadratic equation, minus p minus 3 is equals to 0. So that's what we have there. So as a result, this is a quadratic, so it will give us p into bracket p plus 3 minus 1 p plus 3, which is equals to 0. So p minus 1 p plus 3 will be equals to what? 0. So p is equals to what? 1 or minus 3. So p equals to 1 or minus 3. But if you look at it, the equation, there is nothing like p there. So what they need us to find is what? X. You now come back to your assumption. This is our assumption. So you now tell us when p is equals to 1, what's our value? Our assumption is logarithm of x to base 3 is equals to p is equals to 1 in this case, when p equals to 1. So if you don't forget that this is the power to which this is raised. So we say that x is equals to 3 raised power 1, which is equals to 3. Or when p is equals to minus 3, we have logarithm of x to base 3 to be equals to what? Minus 3. The minus 3 is the power on top of 3 to make it to become x, according to our what? Definition. So 3 raised power minus 3 equals to x. And 3 raised power minus 3 will give us what? 27, 1 over 27. So x is equals to 1 over 27. I think that's the solution to that particular one. So I want you to go and try number 9, number 10. For number 11, I think with what I've done in number what I've done in number 8, you should have idea of what should happen to what number 11. So I will also leave number 11. You know, if you look at number 11, you realize that we also have radicals. We have radicals disturbing there. So what are the radicals? You need to look at it. What's that main radical? So if you look at it, this is the main radical. It's still the same thing as what you have here. So why not represent the radical with something? Well, so go and try it. I'm not going to do that. Bam. So go and try it. So I expect your feedback as soon as possible. So let's move on. Number 5. Okay, I think I've sorted that one. So for today's class, expansion. We want to look at an expansion of algebraic expression. So if you have expansion of things of this nature, how do we expand them? Now you need to know, I intentionally put these things. When you have it like this, what do you mean? When you have it like this, what do you mean? When you have it like this, what do you mean? So please, you need to take note that the form of 3 is different from the form of what? 2 and 1. In 2 and 1, I want to believe that you all know what happened in 2 and 1. That it is only these two. You're only authorized to multiply what you have inside this bracket by 2, not by x. So this one will become what? X plus 2x. X plus 2x. X plus 2x. Then 2 we also multiply minus 5. You know, this is plus times minus. Then 2 times 5, 10. Yes, that's great. So it means x plus 2x will give us 3x minus 10. So that's the answer. Yes, that's a great one from somebody has done. Okay, okay, you just put minus 10. It's not just minus 10, it's 2x minus 10. So the next one, the same way you are going to do this, but the only difference is that this negative will affect what you have. We still have x as x, then minus 2 multiplied by what? Multiplied by minus 2 multiplied by this will give us minus 2x. Then minus times minus plus 2 times 5, 10. So x minus 2x will give us minus x, then plus 10. But if it is now like this, you can see we have both of them have brackets. So it means that 3x we have impact. 3x we multiply x plus x minus 5 plus 2 we also multiply it. So when you want to expand this, the same thing as 3x we multiply x minus 5. Then plus 2 we also multiply x minus 5. So we can just have what? 3x multiplied by this. So that will give us 3x squared minus what? 15x plus, so 2x we also multiply. 2 we multiply x. That will be 2x. Then 2 we also multiply minus 5. Don't forget plus times minus will give us what? Minus. We don't usually have problem when it is plus that precede the bracket. But when it is minus that precede, it must have effect on whatever sign you have inside. It will change the sign. But since this one is plus, it won't change it. That is what you can observe here. The minus here have effect on this minus here. That's why we have it as plus 10 here. So you have to take note of such. So here we are going to have minus 10. So this and this are still of the same family. So you can just have 3x squared. Then minus 15 plus 2 will give us minus 13x minus 10. So that is the solution to that particular one. I want to believe that question 4, 5, 6 can all be done by you. You can do those questions. Can I have a response from the chat box that you can deal with question number 4, 5, and 6 without any problem? So that I move to the next areas that we want to look at. So you can make use of, okay, yes, Bright have said that. Okay, thank you very much. Okay. So, okay, some people have been responding. Okay, all right, so if you can do it, let's move to the next thing. Now, quadratic equation. We have also looked at quadratic equation before, and then there are some other quadratic equation here that I feel we can also look at. These are quadratic equations. Okay, thank you very much. Thank you for all your comments. So quadratic equation now, let's see this quadratic equation. I don't think we have any challenge with this quadratic equation. Question number 1, we should be able to do it. Question number 2, we should be able to do it. You just need to rearrange question number 2. I purposely at least look for those questions in which they are in different forms, so that you know that when you see them in different forms, what you can just do is to rearrange. So in this case now, what you just have to do is, if you need to change this, it means you can transfer all of them to this side. Minus 3x squared, let it come here to become 3x squared. We have plus 2x is not leaving, plus 2x. Then minus plus 1 can also come to this side to become minus 1. So that the only thing you have left on this side is 0. The 0 you have left. All other things you have taken it to. So it means the same thing as 3x squared plus 2x minus 1 equals to 0. So you should be able to solve it now. Now, when you have something of this nature, I think we have also mentioned it, that you can just see this, multiply this 1 plus 3 by minus 1. It will give you minus 3. So having done that, you can now say that what? You look for factors of minus 3. And that it should be given, that should be what? Plus 3x squared plus 3x minus what? Minus x minus 1 equals to 0. So what to replace plus 2 will be plus 3 minus 1x. So 3x is common into bracket x plus 1 minus 1 x. Minus is preceding the bracket. It's definitely going to change the sign here. So you have plus 1 equals to 0. So x plus 1 is common. Then 3x minus 1 is equals to 0. So you can say x equals to minus 1, or 3x minus 1 equal to 0. 3x will be equals to 1. Then x will be equals to 1 over 3. So that's the solution to that particular one. So the same format for this. Now look at number 5. I will also leave you to go and do that. What you just need to do in number 5 is that you have to expand first. You expand. So when you expand, you'll be able to see what and what you can do. So just expand. So expand this. So use x to multiply this. Then expand this equals to 23. So now look at this. When you see anything of this nature, what you just need to do is that either you find LCM or you multiply through by this x that is down. So if I multiply through by x, I multiply this one by x, I'm going to have x squared. I will multiply this one by x. The x down will cancel out. I have minus 12. And I have multiply this one by x. I have equals to x. So I can just bring this one inside. So it becomes x squared minus x minus 12 equal to 0. So we can solve that. Now look at this number 7, 8, 9. They say find the possible values of x over y if this. So what you just need to do there, I'll give you the clue. You go and do it. So what you just need to do is that you need to make sure that our time is, we need to finish this now. Okay. So what you just have to do here is what? We are looking for x over y. And you can only see x squared, xy, and so on like that. So you can just divide through, since what should be at the denominator is y. And the highest power of x that we have here is what? Is 2. Highest power of x is 2. So to convert all the x that you have into x over y, you need to divide through by what? Y squared. So divide through by y squared. If you have to do that, it means you are going to have what? S squared over y squared. Divide everything you see by y squared. Plus xy over y squared. Minus 6y squared over y squared. Equals to 0 over y squared. So you have been able to do that. Divide through by that. So having done that, you see that y we cancel one y here. Y square we cancel y square. And this will still give us 0. So this x squared over y squared is still the same thing as x over y. Everything squared. Plus x over y. You can also bracket it. Minus 6 equal to 0. So if you have this, what you can just do, you can solve it like this too, is a quadratic equation. But if you feel it may confuse you, just make sure that what? X over y, you can say let x over y be equals to a. So that we have it as a squared plus a minus 6 equal to 0. So you can see that you can now get the value of a. This is a quadratic equation. You can solve it and get the value of a. So once you get the value of a, that is the value of x over y. So number 8, go and look at how you can do it in that manner too. Then look at how you can do number 9 too in that manner. So I want to leave that to you to do that. I will appreciate if you can get back to me. So I will post for those that are just joining us today. Very soon, before the end of the class, I'm going to post the link, the WhatsApp link to our WhatsApp group, so that you can always have my contact there to get back to me. So let's move to the next thing. Now, polynomials. What do you mean by polynomials? You can see we are just getting to polynomials. We have actually used like 1 hour to treat prerequisites. So polynomials, what do you mean by polynomials? Polynomials, from what you can see here, is the sum of separate terms of positive powers of variables with a constant term. Although the constant term can be 0, it doesn't matter. So when you look at this definition, it means that our quadratic equation is also a polynomial. Quadratic equation or quadratic expression is also a polynomial. So anytime we have separate terms of positive powers of variables, so that is what we mean by polynomials. So majorly start from quadratic. So x squared plus 4x plus 1 is an example. This is the constant term. Sometimes the constant term can be 0. So it could also be like this, x squared plus 4x. This is also a polynomial. So I've also tried to drag some examples of polynomials here. So all these ones, they are examples of polynomial. Actually, I've tried to restrict us to cubic. You know, this is quadratic. When the power is 3, it is cubic. So when the power is 3, it is cubic equation or cubic expression. So this is cubic. I think most of the examples I've made use of here, they are cubic. So this is a cubic polynomial. So all these ones are examples of polynomials. Now, some terms may also be missing. Any term can be missing. Look at the P1 there. I can also have another example as sometimes we also, because it's a function, polynomial is a function. It is a function, we can also say it's a function. So f of x, we can see that f of x is 2x raised power 3 plus 5x minus 7. You can see that there is term in x raised power 3, but there is no term in x raised power 2. So it is possible. So any of those terms may be missing. It's not as if it's missing, but it's just because the value of the coefficient is 0. So this one that I have here, I may rewrite it as 2x raised power 3 plus 0x squared plus 5x minus 7. So meaning that the coefficient of x squared is 0. So it could also be like that. So those are some of the things that you also need to know about. I want to believe that this person is also learning. So that is, now when you know the polynomials, those are examples of polynomials. How do we add them together? Okay, you don't understand. From what I've explained so far, I've only explained what is the definition of polynomials. It says the sum of separate terms of positive powers of variables. Okay, another thing, let me explain it from this angle too. What we call, when we say polynomials. Okay, so another thing is that it's not from polynomials. Poly, if you try to look at the formation of that word polynomial, it means poly. We can start from what we call monomial. So any number, a single term, is what we call monomial. X is a single term. This is a monomial. 5x is a single term. This is a monomial. 20x is a single term. This is a monomial. From there, it means mono. Mia is number. Mono is 1. From there, we also have what we call binomial. The bi there is talking about 2. Nomia is number. We have 2 different kind of numbers. So For this one too, we may also have just one as a monomial. But by the time we combine x plus 1, this is what? A binomial. 1 is a monomial. Just ordinary 4 is a monomial. So by the time you can see they are not of the same family. You can't say x plus 1 equals to 1x or 2x, because you can't add them together. They are different terms. They are separate terms. That's what they are trying to say. Sum of separate terms of positive powers. So that is what we, so apart from that, we also have what we call trinomial. Trinomial means 3 numbers. An example of trinomial is our quadratic equation. So it is from trinomials and so that we have what we call polynomial. Polynomials start from tri. So poly starts from tri. So we have we can have 2x squared plus x plus 5. So this is a trinomial or polynomial. So that is what we mean by polynomial. So I said these are examples. So you start from here. So those are examples of polynomials. So when you now have what we call polynomials, how do we deal with them? How do we add them together? How do we subtract them? So we have some examples here. They have given us P1. They want us to add them together. So how do we add P1 together? P1 and P2. So you just add term-wise. Term-wise. You don't add x raised power 3 to x raised power 2. No, they are not of the same family. So you add term-wise. If a particular thing is there and it doesn't have a family, so it means it will stay alone. You don't add such a person to another family. So you can only add, so x raised power 3 is a family on its own. X raised power 2 is a family on its own. X is a family on its own. The one without x is a family on its own. So they should not be added to what? Another family. That's the golden rule there. You must follow that rule strictly. When you are adding or you are subtracting, you don't add a particular term, a number, to another number in to another term. So you add them term-wise. So P1 plus P2, I can just rule here and say that 2x raised power 3 plus 1x raised power 3. It will give me 3x raised power 3. Minus 3x squared plus x squared. You know, it's like minus 3 plus 1. Minus 3 plus 1. So what is minus 3 plus 1? I am owing Madam A 3,000 naira. And I have 1,000 naira with me. If I need to pay that 1,000 naira, it means I'm still owing 2,000 naira. So my answer would be what? Minus 2. So minus 2x squared. We also have plus 5x minus x. So that's 5x minus 1x. And that will give us plus 4x. Minus 7 plus 1. Minus 7 plus 1. That will give me what? Minus 6. So that is the answer to P1 plus P2. So you have to take note of that. There's another question there, say P2P1 minus 3P2. It means my P1, I need to multiply it by 2. If I multiply P1 by 2, what am I going to have? If I multiply that, if you know you have anything to raise, please, you can always make use of the chat button. Writing on the screen is not allowed. So P1, I'm going to multiply by, so if I multiply that, so Okay. Sorry, let me share that. Okay. So now, if you need to add that, so if you are adding, what do we do? It said 2p1. So multiply everything here by 2. I'm going to have 4, 2 times 2, that's 4x raised power 3. Multiply 3 by 2, I'm going to have 6x squared. Multiply 5 by 2, I'm going to have 10x. And I'm going to have what? 14. Minus 3p2. So multiply everything here by 3. I have 3x raised power 3 plus 3x squared minus 3x plus 3. So what will I get? Now, I have to be very careful. 4 minus 3 will give us 1. So I have x raised power 3. Then minus 6. Look at it. Minus 6. Please be attentive. Minus plus 3. That will be minus 6. Minus times plus will give us minus. That will be minus 6 minus 3. And that's what? Minus 9x squared. Then for this again, we have plus 10x minus 3x. No, plus 10x. You may just cancel the x. Plus 10 minus 3. Please observe. So minus times minus is plus. So it will be plus 10 plus 3. That will give us what? 13x. Please, nearly doing it like this. Somebody will just say the answer is 7. No. That's why you have to be very careful. 10 minus 3. So then minus 14 minus plus. Minus 14 minus plus 3. So that will be what? Minus 14 minus 3. And that will give us minus 17. So minus 17. So that's the answer to that particular question. So I want to believe you understand what we have done so far. Please, you can always call my attention if there's something that you don't actually understand there. So you can just screenshot it. And then, so let's move to the next aspect. Now look at this multiplication. How do we multiply? We have talked about addition. We have talked about subtraction of polynomials. How do we multiply a polynomial? So I think that's why I gave as a prerequisite expansion. So it's similar to what we do in expansion. So in this case, we are multiplying 2x raised power 3 minus x squared plus x minus 1. You are multiplying it with what? 3 minus 2x. So what you just need to do, it depends. Just like we do our normal normal expansion. You dismantle one bracket, you may decide to dismantle this one because it's just a binomial. So dismantle this, it means you are going to use 3 to multiply. You also use minus 2x to multiply. So at the end of the day, it's going to give us 3 into bracket 2x squared x cubed minus x squared plus x minus 1. So you have used 3. You also use minus 2x into bracket 2x raised power 3 minus x squared plus x minus 1. So that is what it will give us. So can we expand? So we have 6x raised power 3 minus 3x squared plus 3x minus 3. You do the same thing for this. Minus 4x cubed. Sorry, minus 4x raised power 4. Then minus times minus plus. Then it will be 2 times, that will be what? 2x raised power 3. Minus times plus. And I want to believe that the student doing that is a responsible student. So with what we have, we can just have, so it will be minus times this. That will be minus. So that's just how we can do that. So I want you to try. I want you to try the rest. So please, can you try the rest and then? So can you try? Okay, this is division. Okay. Before we go to division, I want you to, in the next couple of minutes, let's just relax a little bit before we. So if you have any question before we move on, please. Okay, yes. Very good one from Farida. Okay. So, okay. So if there's any question, I'm trying to go back to, okay. Yes. For this one. Okay, for the previous, okay, this is it. The previous question. So minus 2x raised power, that's minus 4x raised power 4. Minus times minus, that's plus 2x raised power 3. Okay. Okay. And after explaining, just collect like terms. Then we have what? Minus 2x squared minus times minus plus 2x. So now look at the terms that are of the same thing. This is the highest power. So you can bring it out minus 4x raised power 4. Followed by x raised power 3. We have x raised power 3 here, x raised power 3 here. They have the same family. This is 6. This is plus 2. So when you add them together, it will give you what? Plus 8 x raised power 3. This is the family of s squared. S squared minus 3 minus 2. That's minus 5 s squared. The family of 3x, the family of x plus 3x plus 2x. That will give us plus 5x. The family of number constants minus 3 is the only one there. It has no relative, so it's going to stay alone. So this is the result of our multiplication. So I want to believe that. So that's what we need to do. So I want to believe that you can just lay your hands on the remaining ones. Let's quickly move to one or two other things. Okay. Yeah, so to move to the, yes, I think somebody is saying something. Okay, yes, so let's move. Division. Division is also an area that we also need to look at. Now, before we go to division of polynomials proper, I want to take us back to the way we have learned division in primary school. For example, if you need to divide 9 by 2, we need to make division of 9. So 9 divided by 2. I remember that then we'll go to our log division, we draw a table like we'll draw a line like this. We put 9 inside and we put 2 outside. Then we say that what? 2 in 9 is what? Is 4. So 2 in 9 will give it as what? 4. So when you have 4 as your answer, we have 4. Then we'll say 2 times 4, 8. We write 8 here. Then we'll say that 9 minus 8 is what? 1. Exactly. So at the end of the day, we'll say 9 over 2 is same thing as what? 4 whole number, 1 over 2. Am I right? I think that's the way we learned it then. So let's look at what we have used here. The first thing is that we divided. Now, how many times can 2 go in 9? That is division. So having done that, we say it is 4 times. The next thing is that we now said 2 times 4. That is multiplication. Having done that, we now said that what? 9 minus 8. That is what? 1. That is subtraction. You know, if it is that we have more than this, maybe we have just 90, maybe we have 95, for example. If you have 95, that's the same way you are going to do it. You say 2 in 9, it is what? 4. 2 times 4, 8. Then we subtract 9 minus 8, 1. We now break down this 5. It becomes 5 like this. So it becomes 15. The next thing we also do, we also reverse what you have done before. As in the process, you divide again. How many times can 2 go in 15? Then we say it is what? 7 times. 7 times 2, 14. That's multiplication. Then you also say that for 15 divided by 4, 15 minus 14, that's 1. That's the remainder. So I want to believe that you understand, you remember this. I'm just trying to refresh our memory with that. You don't understand? Okay. Now let me go back. I'm saying that when we're in primary school, the way we learned division, is through this method. We call it long division method. I hope I'm right. I think that is what we call it. So I'm now saying that let's assume that we want to divide 95 by 2. Okay, you understand now. So that is what I've done here, 95 divided by 2. So at the end of the day, it means we say that 95 over 2 is same thing as 47 whole number. Remember 1 over 2. This one we have here, we call it quotient. This one here, we call it dividend. This one here, we call it divisor. And this one here, we call it remainder. So at the end of the day, when you are expressing, you express as quotient, whole number, then remainder over divisor. So that's why we have 47 over 1 over 2. Please, I want you to, because this is the concept we'll be using to divide in polynomials. So when you understand this concept very well, we won't have any problem at all when we get to polynomial, when we want to use it on polynomials. If you can use it on numbers like this, then we should be able to use it on polynomials. So now let's see how we can use it on polynomials. So for us to use this on polynomials, don't forget, we are performing 3 operations. The operations we are performing are division, multiplication, and subtraction. Now let's pick the first question. We want to divide. The divisor will be outside, x minus 2. Then you have the dividend, x raised power 3 plus 3x squared minus x plus 1. Now, for you to carry out your division here, you pick the highest power here, the term with the highest power, and the term with the highest power here. So the term with the highest power here is x raised power 3. The term with the highest power here is what? X. So you carry out the division on them. So it means you are going to have x raised power 3 divided by x. That's what you are going to do. X raised power 3 divided by x. You all know that according to law of indices, it will give us x raised power 2. So x raised power 2. Put it up there. So having done that, you can now multiply. So we have done division. Go to multiplication. Multiplication now will be carried out on everything outside. You use s squared to multiply everything outside here. So s squared multiplied by x will give us x raised power 3. S squared raised multiplied by minus 2 will give us minus 2s squared. So then you carry out subtraction. You can see that we have multiplied. Then the next thing is for you to subtract. So when you are subtracting x raised power 3 minus x raised power 3, it will cancel out. It will go out to give us 0. Now 3 minus minus 2. 3 plus 3 minus minus 2. That will be plus 3 plus 2. That will give us 5s squared. You can see other ones does not have a term. So just transfer them down. Minus x plus 1. We do the same thing. The highest power here is 5s squared. The highest power here is still x. So 5s squared divided by x. So x we cancel 1x. We are left with plus 5x. Plus 5x. So we have done that division again. You carry out multiplication. 5x multiplied by x. It will give us 5s squared. 5x multiplied by minus 2 will give us minus 10x. So the multiplication has been performed. So you mark that. You go to what? Subtraction. So let's subtract. 5s squared minus 5s squared. It will always give us 1. Yes, 0. Then minus 1x minus minus 10. Minus 1x minus minus 10. So that will be minus 1 plus 10. Minus 1 plus 10 will give us what? Plus 9. So that will be 9x. Then transfer this one down, plus 1. So from there, you also see what's the highest power here? 9x. What's the highest power here? X. Can they still divide? Yes. 9x divided by x. X we cancel x. Then we have what? Plus 9. So you now use 9 to multiply everything. 9 times x, 9x. 9 times minus 2, minus 18. So you have carried out multiplication again. So you what? You divide, you subtract. 9x minus 9x, it will always cancel out to give you 0. 1 minus 18. That's what? 1 plus 18. That's 19. So it means this is our quotient. When you divide x raised by 3 plus 3x squared minus x plus 1, when you divide it by x minus 1, this is our quotient. And 19 is our remainder, while x minus 2 is our quotient. So let me pause here and take our question. I can see that today is somehow tough. So let me pause here and take our question. I will also use the opportunity to post our link. I will use it to post the WhatsApp link so that for those that are just joining today, they can always be part of the group. So please, I did your comment before we proceed. I can see that it's been tough. Is it this one? Yes. Today's class is somehow tough. I can see that. So let me just pause here. I still have a lot to give, but let me just pause here and get our feedback. I've posted the link to the WhatsApp platform now. So please, if you have anything to say, so please, you can check if you are not in our WhatsApp group, you can always use that link now. If you have anything, any comment at all, so you can, I will appreciate if you can just raise your hand. Let me hear your comments before we proceed. So, any comments so far? You understand what I've been teaching? If you have any whatsoever, you can just. So please, you can raise your hand so that I unmute you to talk. Okay, I'm yet to see anybody. I want to believe that so far there has not been any problem. Okay. Okay, Abdulalim. Okay, the link for the WhatsApp. Okay, I will send. Okay, I've sent the link for the WhatsApp. Yes. Okay. Okay. All right. You're welcome. I think with what I can see now, from what I can see, it's like you are getting my explanation. So I can move on to complete today's the content for today's class. We just have what we have left is just remainder theorem and factor theorem. Now look at this division that I've done now. I got 19 as the remainders. There are sometimes they ask questions that find the remainder. So is it all the time that I need to go through this? Do I need to go through all this stress every time I want to find the remainder? No. The major reason why we need to go through this stress is when we need quotient. There's another way in which we can get our remainder directly without going through this stress. And that is what we call remainders theorem. That's what we call remainders theorem. So we are going to look at that one too. But before we go to remainders theorem, let me go over the question number 2. Let me go over question number 2. Let's go over it together. Now for question number 2, this is our divisor. It will be placed outside. So put it outside. So I'm going to have x squared minus x plus 1 here. And inside there, I'm going to have x raised power 3 plus 3x squared plus 1. So if I have this here, so let me try to, I can see that maybe somebody also just joined. Once again, I'm reposting the WhatsApp link. So now, if we need to divide here, so what's the highest here? The highest power, the highest term here is what? X raised power 3. The highest here is what? X raised power 2. So x raised power 3 divided by x raised power 2. So according to law of indices, it becomes 3 minus 2. That is x raised power 1. So just x. So x. Now we have done division. The next thing is what? Multiplication. You now use this x to multiply everything. So x times x squared will give us x raised power 3. X multiplied by minus x will give us minus x squared. Now, x multiplied by 1 will give us plus x. You can see that the family of plus x is not there, but just put it here. So you can add 1 and x together. So be very careful there. So we have done, we are done with multiplication. The next thing is to go to subtraction. X raised power 3 minus x raised power 3. It will give us 0 to cancel out. So 3x squared minus x squared. So it's just 3 plus 3 minus 1 x squared. So it becomes 3 plus 1, that is 4. So we have 4x squared. Then it's very, you see, you have to be very careful. Look at this. Look at this. There is no term in x here. I told you when there's no term, it's the same thing as we have 0x. 0x. Assume you have 0x. So it will be what? 0 minus plus 1. 0x minus plus 1x. So that would be 0x plus times minus 1x. 0x is nothing already. So it means our answer is what? Minus 1. That's 0 minus 1. 0 minus 1 will still give us minus 1. So that would be what? Minus 1x. You can see it's not plus x, so it's minus. Then this plus 1 that you have here, you see it is up. It has no family here. So, or you have 0 here. So that would be 1 minus 0. It should give us what? Plus 1. I hope you get the logic now. Plus 1 that is up, we are bringing it down directly. But if it is something that is down, that does not have any family, it means that what? Such a letter will attract a negative sign. So that is what you can see there. So you also go one round again. The highest power here is what? 4x squared. What's the highest power here? S squared. 4x squared divided by x squared. This cancels this. We have 4. So plus 4. So if you have plus 4 there, you now what? Multiply 4 times x squared. 4x squared. 4 times minus x, minus 4x. 4 times 1 plus 4. So this one we cancel this. Minus x, minus 1x, minus 4. That's minus 1 minus 4. That will give us minus 1 minus times minus plus 4. So minus 1 plus 4 is equal to 4 minus 1. That is 3. 3x squared. Then 1 minus plus 4. 1 minus 4. That's minus what? Okay, sorry. It is not squared. So 1 minus 4 will give us what? Minus 3. So this is the answer. That will be 3x minus 3 is the remainder. No, you can see now. You have to, if you look at the highest here is 3x. Can you divide it by x squared? No, it will not give us a polynomial. Because a polynomial from our definition, they say positive powers. Positive powers. Positive powers. So that is what you can, that's how we can do that. So far, so good. We say carry out the following division. Write each result in the form P equals to that polynomial equals to divisor times Q over R plus R. What they are just trying to say is that, for example, in the case of 95 over 2 that we did, we got 47 whole number, 1 over 2. So they said they don't want you to write it like this, but write it as 95, which is the polynomial, is equals to divisor. What's the divisor here? 2. 2 times quotient. The quotient is 47. 2 times 47 plus the remainder plus 1. So 95 is the same thing as 2 times 47 plus 1. As 2 times 47 will give us what? Will give us 94 plus 1, it will give us 95. So this is the way they want you to express it. So I will leave you to that. The last aspect that I want to look at is the aspect of remainder theorem. Remainder theorem and factor theorem. Now say we don't need to struggle and then say, okay, let me struggle, I do that particular. It's not every time that we do that long division. There are sometimes we can just get it straightforward. Look at question number 2 that you can see here. They find the remainder when f of x, which is this, is divided by x minus 3. I don't need to go and do long division method here before I can get the answer, the remainder. Since I'm looking for the remainder, it is only when I need the quotient that I may be rushing to do what? That particular long division method. So what I can just do here, that is what they call, said when a polynomial f of x is divided by x minus a, the remainder is the value of f of a. The remainder is the value of, okay, sometimes I love to put it as the remainder is the value of f of x is equals to a. Now, how did you get that? So, how did you get that? What we just do is that what? We are dividing by x minus a. I just need to equate that x minus a equal to 0. I equate it to 0. If x minus a equal to 0, what is a? What is x? Minus a will go to that side. X will become what? A. So if x is equal to a, then I will now, anywhere I see x in that equation, I put a there. That's why we place x here with what? A here. So if I want to apply it on this particular question, say find the remainder when f of x equals to this is divided by x minus 3. I just need to go to x minus 3. Okay. I need to go to x minus 3. When I get to x minus 3, I will just what? I will now equate it to 0. Okay, don't worry, I'll be explaining. So I want to explain with this particular question. So I just need to equate x minus 3 to 0. It becomes what? X is equals to 3. So I will now come here. Anywhere I see x, I will put what? 3 there. S is 3. F of x equals to 3. That will be my remainder. The remainder would what? F of x is equals to what? 3. So anywhere you see x here, insert this 3 there. So I'm going to have 4, 3 raised power 3, plus 3, 3 raised power 2, minus 2, 3, plus 5. So x 3 raised power 3 is what? 27. 4 times 27. Plus 3 times 9. Minus 6 plus 5. So 4 times 27. We give what? 4 times 7 is what? Is 28. This 2 times 4, 8. So that will give us 108. I hope I'm right. 4 times 7, yes. Yes. Then plus 3 times 9, 27. Minus 6 plus 5 will give us minus 1. So 27 minus 1 is 26. 26 plus 108 will give us what? That's the 26 plus 108 will give us 134. It means the remainder when f of x raised power 3 plus 3, when the f of x equals to 4x raised power 3 minus plus 3x squared minus 2x plus 5 is divided by x minus 3. So the remainder will be 134. Another thing we can, before we go on, let's come to the one we have solved. Look at this that we solved the other time. We can also try it there. We have got 19. Let's see whether we are going to get the same thing. X minus 2 equate it to 0. X minus 2 equals to 0. X will be equals to what? 2. So if x is equals to 2, just come here. Anywhere you see what? X, put 2 there. So our remainder will be equals to what? Our remainder will be equals to 2 raised to power 3 plus 3, 2 raised to power 2 minus 2 plus 1. 2 raised to power 3 is 8. 2 raised to power 2 is what? 4. 4 times 3, 12. Minus 2 plus 1. So 12 minus 2 is 10. 10 plus 1 is 11. 11 plus 8 is what? 19. So you can see that we have got the same thing with this. Instead of going through this journey, we can usually, if it is this one we are looking for, the remainder, we just use remainder theorem. But if we need the quotient, the remainder theorem cannot produce the quotient for us. So that's one thing that you need to know there. So, but what factor theorem is saying is that that when you have for factor theorem, it's saying that when the remainder is 0, it means x minus a is a factor. If you want to divide by x plus a, or maybe x plus 2, if you are dividing by x plus 2, it means you are supposed to say that equals to 0. X will be equals to minus 2. Whatever you are going to divide with, you equate that into 0. Okay. To round up today's class, I'm going to solve this question. When the polynomial f of x equals to 2x raised power 3 minus ax squared plus 5x plus 1 is divided by x plus 2. The remainder is minus 1. Find the value of what? A. You can see that here they have given us the remainder already. but they have hidden a particular term. They have hidden this. So if you need to do that, you just go to x plus 2. That is the divisor. Equate it to 0. X plus 2 equals to 0. X is equals to minus 2. So instead of having just f of x, exchange, replace all x with minus 2. Our remainder is equals to this. So we have 2 minus 2 raised power 3 minus a minus 2 raised power 2 plus 5 minus 2, then plus 1. The remainder is what? Minus 1. As they have painted it here, the remainder is minus 1. So let's see. Minus 2 raised power 3 will give us minus 8. Minus 8 times 2 will give us what? Minus 16. Minus 2 raised power 2 will give us plus 4. Plus 4 multiplied by minus a. That's minus 4a. Minus plus times minus minus 5 times 2, 10. Plus 1 is equals to minus 1. So connect like terms. We have minus 4a. Minus 16 minus 10 will give us what? Minus 26. Minus 26 plus 1 will give us minus 25. Is equals to minus 1. So minus 4a will be equals to minus 1 plus 25. Minus 4a will be equals to plus 24. Divide both sides by minus 4. Minus 4a over minus 4 equals 24 over minus 4. And our a will be equals to minus 6. So a is equals to minus 6. So that is what we are going to use to round off today's class. It has been a very nice one that you actually paid attention. So I just want to encourage you that you try as much as possible. Any problem that you have been given, try to solve those problems. Try to solve those problems. I think I'm going to add, I will be sending this note possibly tomorrow morning to the WhatsApp platform. So I'm going to have some questions that I want you to go through. I think I must say it that the 2 hours is not enough to do a lot of things. So, but we just have to abide by that. I remember that there are some aspects that we have not even touched in indices and logarithm, which you can also come across. So likewise in polynomials too, we have not been able to finish it. But at least with what I've given you, I just need you, what I've given you is just like a push. I've given you a push. With that push, can you go on and at least make research and get back? So you don't expect me to give you everything that you need. I've given you a push. So these are like a push. So I will be interested in you going extra mile to see 1 or 2 questions and make you come back with questions. So I've done this, I've not been able to get this. So I can't give everything within this time. So even if I have another extra 2 hours again, I can't give enough. I can't give everything. There are lots to touch. So please, we always want you to try as much as possible, make research and come back with your questions. So I think this is where we are going to end it. So if you have any comment, you can just raise your hand and then let's take the comment. So I'm going to add some questions as exercise that I expect you to also go over at the weekend. So it's been a nice one with you. I really, at this time that we can still see students that are interested in something of this nature. So it's at least it's a kind of encouragement, it's a motivation for some of us teachers. So please, if you have any comment, you can just make your comments before we end it. So next week, we are supposed to move to calculus, but I think I'm going to get back if we need to go to some aspect of permutation and combination before we move to calculus, so that we can treat calculus as maybe the last time. So that today is the end of the 3rd week out of the 6 weeks. So thank you very much for appreciating. Thank you. So I will also appreciate if you can try as much as possible to do your assignment. So it will be nice if you do your assignment. I will appreciate that. So thank you very much. If there's no comment, I think we can actually end the section. Okay, Madam Sibga, well done, you're welcome. I hope your work is going on fine. It's unfortunate that your further maths work will be on Tuesday or so. Okay, but no problem. If there's any, you can always private chat me if there's anything to revise with you. So all those that are writing WAEC further maths by next week Tuesday, there's no problem. You can just if there's any aspect that you feel we need to go over, so you can let me know. Just private chat me. I will be available to take you through it. So I wish you best of luck in your exam. Okay, I will post it on where you can watch it. I will do that. I'll post that on the group. Just try to join the group. Try to join the group. Once you join the group, I will send the link through the. So thank you very much. Have a nice, wonderful night.